This week we're going to talk about one of the new features in MetPy, which is downdraft cape or DCAPE. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I wanted to talk about a new feature in MetPy, which is downdraft cape or DCAPE. And here I'm pulling up a sounding analysis from the Storm Prediction Center. So here we got the 0Z sounding from January 23rd at San Diego, and you can see that we have a DCAPE of 642 joules per kilogram approximately. And just as a reminder, MetPy has been able to shade areas of CAPE and DCAPE since almost the very beginning. And we were able to calculate CAPE in many ways for quite a while now. But actually calculating DCAPE is new. And DCAPE is the negative buoyancy or the negative convective available potential energy to a parcel. So when the parcel is colder than the environment, it's going to be negatively buoyant. And so the integral of the area between the parcel path and the environment here is DCAPE. All right, now that we've got that cleared up, let's go look at how we can calculate it. First, we're going to need to do all of our imports. We know we're going to need to get data. We're going to need to be working with units. We're going to need to work with date times, and we're going to do calculations. So I'm going to import metpy.calc as mpcalc. From datetime, I'm going to import the datetime object. From metpy.units, I'm going to import the units registry and the pandas data frame to unit arrays helper. And then from siphon.simplewebservice.wyoming, we're going to import the Wyoming upper air object. Now we need to get the data. So we're going to have our date. And it's good to do this at the top and make them variable so it's very easy to change and play around with different dates, different sounding stations. We're going to go with 0Z, January 23rd. And the station is going to be NKX. From the Wyoming upper air class, we're going to use the request data method. Pass it our date and station. And we got a 503. The server is too busy to process your request. Please try again later. You do get this sometimes from the Wyoming archive. And we run the cell again, and it's working fine. If we look at the head of that data frame, we see all of our fields, and we have data. What we do need to do is turn this into unit arrays because the calculations in MetPy are unit aware, and we're going to need to add that unit information. And of course, the easiest way to do that is with the pandas data frame to unit arrays helper. We pass our data frame to it, and what we get back is not actually a data frame, but it's a dictionary, and it's a dictionary of united arrays or quantities. So for example, we see we've got pressure in hectopascal. Let's go ahead and get rid of that cell so we don't have all that to scroll through. Now calculating DCAPE is actually relatively straightforward. We just pass the pressure, temperature, and dew point data. And you may not remember, do I need to pass a profile? Do I need to pass surface temperature or temperature at some level? All these sounding calculations require something a little different. You can just look at the doc string. And remember, I pulled up this pop-up documentation by using Shift-Tab in the notebook. So my parameters are pressure profile, temperature profile, and dew point profile. So for that, from my data frame, or now my dictionary of unit arrays, we'll get the pressure, temperature, and dew point. When we run that, we see we actually get quite a bit in the return. I get a DCAPE, which is good, but I also get these arrays, something in pressure and something in degrees Celsius. My pressures are going from pretty high, 991, up to 620. So we may be able to take some guesses at what these are, but let's just go back and look at our documentation. It returns three things: DCAPE as a pint quantity, downward pressure, pressure levels of the descending parcel, down parcel trace, the temperatures of the descending parcel. All right, great. So now we know what we have. I don't really care about the downward parcel pressures or temperatures right now. I just want DCAPE. So I'm going to use Python's unpacking syntax and assign the variables that I don't care about to underscore. So I'm going to save DCAPE and basically throw those other things away. Now if I look at DCAPE, I get 649.9 joule per kilogram. If we go back to the SBC, their calculation yielded 642. So we're very close. Okay, we can go one step further and make this notebook have a nice output and show off some cool things that you can do with f-strings that you may not know. So I'm going to say the DCAPE and then we'll put our time in for station. Our station name is DCAPE. Remember, whatever I put in the curly braces are going to get replaced with the contents of that variable because this is an f string. We have that preceding f. And we do get a sentence, and that is some nice string output that would take a lot more effort to do in any other language. But I want to clean this up. I don't need all of this precision here. It's meaningless. The station's fine. And the date, if assuming I'm working with current data, I don't need the year, and I don't need the full minute and second timestamp. So let's start out with the DCAPE. I'm going to put a colon to say I'm going to specify formatting. 0.0f means give me a floating point with no digits after the decimal. And you see that rounds to 650 for us. What about date? This is the really cool one with f-strings. I can, after the colon, put my standard date time formatting characters for a month, day, space, hour. I'll put a Z out here. And now we have a sentence: DCAPE at 01-23 00Z for station NKX is 650 joules per kilogram. So this is another one of those features that has been requested in MetPy for quite a while. Now it's there. You can go calculate DCAPE. It's very easy to use, and hopefully you learned something about f-strings along the way. Thanks for joining me, and I'll see you on next week's MetPy Monday.